There are a number of locations in Australia that would be suitable for small power plants as opposed to the multi-100 megawatt scale of power plants that people are used to. A smaller power plant requires a smaller cooling tower. The project that we've been working on out at Gatton, at the UQ Gatton campus, is a prototype natural draft dry cooling tower suitable for a small power plant. All power stations require cooling towers. It's part of the energy production process that you need to remove heat from the process. And that's common to all power stations, be it a coal power station, a nuclear power station, or a solar thermal power station, or a biomass station. They all require cooling towers. This system uses minimal amounts of water, and the water that it uses is quite often water that's not suitable for other purposes like drinking. The tower is composed of an exterior steel truss that supports both the heat exchanger bed and the fabric membrane that makes up the body of the tower. From a bird's eye view, the heat exchangers would look like a giant car radiator, and the heat coming off the coils of the heat exchangers are what provides the force to drive the airflow.
The people that would be interested in this technology is the people that need to generate power in regional and arid areas. So particularly remote communities and mine sites are looking for ways to more cost effectively generate power, especially those that have an excellent solar resource, they have a lot of sun, or that have access to a good geothermal resource.
The cooling tower can be used for geothermal power plants as well as solar thermal and even non-renewables, biomass and other types of power generation technologies. The cooling tower actually moves the air using natural draft instead of fans, so it means that it doesn't have to consume electrical power. As a result of that, you can generate more power when you've got natural draft dry cooling tower.
This project came about as a way of the Queensland Geothermal Energy Centre of Excellence, which is a part of the University of Queensland, to further the technology and reduce the cost of putting geothermal energy in Australia. And it was actually sponsored and funded by the Queensland State Government.